Did you know that the universe hides many secrets that astronomers will never be able to decode? Our universe is like the ultimate puzzle, just one big and complicated bag of surprises. From the mystery about our universe's inevitable death to the mystery about how galaxies form, the following are some mysteries of the universe.
70% of our universe is made up of something so weird and so strange, it continues to baffle the world's brightest minds.
It is crying out for some new breakthrough, new thinking.
We are absolutely still lacking great ideas.
The ancient astronomers stared up at the sky a long time ago, scratching their heads over comets and stars. They didn't know what they were made of or how they worked. Now, thanks to modern science, we've cracked those codes. But every time we build a bigger telescope or invent a cooler gadget to study space, we discover even more questions waiting to be answered. In this collection of the biggest cosmic mysteries, you'll see how much we've learned and how much we still don't know. Spoiler alert: the universe is the biggest mystery of all. So, let's dive into the mind-bending unknown and explore some of the wildest puzzles. First, how do galaxies form? Galaxies form thanks to one of the universe's favorite tricks: gravity. When the universe was brand new, the matter wasn't spread out evenly. Some spots had more stuff than others. These denser areas pulled in even more matter over time, growing bigger and clumpier while the emptier spots became even more empty. That's how the first lumps of matter grew into galaxies, like our Milky Way. Even though the universe was expanding, gravity kept tugging on these patches of matter, bringing them together. To study how this works, cosmologists run massive computer simulations like the famous Millennium Run, created by scientists at Durham University. Yep, they can actually build a whole universe inside a computer. Then they compare their digital galaxies to the ones we see in real life. Here's the cool part. One simulation coincides with what we observe. It shows a universe filled with invisible, dark matter, which doesn't interact with normal atoms but still has a gravitational pull. According to this model, galaxies are connected by long, thread-like structures called filaments, and some evidence backs this up. But there are a few hiccups. The model says large galaxies should have tons of tiny galaxies orbiting them, but we don't see that many. Scientists aren't sure how the first massive galaxies appeared so quickly after the Big Bang. So, while we've got a pretty good idea, the full story of galaxy formation is still waiting to be written, just like we are waiting for answers to the big question: is our solar system unique? The idea that our solar system might not be one of a kind is pretty mind-blowing, especially considering we didn't even know other solar systems existed until the mid-1990s. Before that, astronomers had only found a few planets orbiting pulsars, dead stars that blast out deadly X-rays. But planets around stars like our Sun? That was uncharted territory. Fast forward to today, we know our solar system isn't alone. Astronomers have discovered thousands of exoplanets orbiting stars across the galaxy. Some of these systems are wildly different from ours. There are hot Jupiters, giant planets that have spiraled super close to their stars, stirring up chaos and booting other planets out of orbit or onto wild, stretched-out paths. It probably wouldn't make it if a small Earth-like planet got caught in that kind of cosmic pinball game. But here's the twist. While telescopes can find massive, unusual planets easily, they can't yet spot a system like ours, a calm, orderly setup with small, rocky planets like Earth. However, future telescopes should be able to, and some scientists think systems like ours might be pretty common. After all, nature rarely makes just one of anything. So, is our solar system rare? Maybe? Unique? Probably not. We're just one piece of a much bigger cosmic puzzle. One such cosmic puzzle is the cause of the Big Bang. The Big Bang is one of the biggest puzzles in science. We know it's the event that kicked off the universe about 14 billion years ago, but the big question remains: what caused it? It's like asking, what lit the fuse on the cosmic fireworks? To figure this out, you'd need to imagine something that happened before the Big Bang. But here's the tricky part. The Big Bang might not have created matter and energy, but also space and time itself. If time started with the Big Bang, the idea of before doesn't make sense, like asking what's north of the North Pole. This is why some scientists have explored wild theories to avoid the idea of the universe popping out of absolutely nothing. One older idea was that the universe would eventually collapse back on itself, triggering another Big Bang, like an endless cosmic bounce. But now we know the universe is expanding faster and faster, making that scenario unlikely. A newer idea is even stranger. Some physicists think our universe might be part of a bigger, multi-dimensional space called the bulk. In this view, our four-dimensional spacetime could have collided with another universe floating nearby, creating the Big Bang. It's like two giant sheets brushing against each other in a higher dimensional space. And if you think that's mind-bending, here's the kicker. If something caused the Big Bang, what caused that? The deeper you go, the more it feels like peeling an onion of infinite mysteries. And shouldn't you, especially when you don't even know how the universe will end? The universe might not have an expiration date, at least not one we can pinpoint. Stars die, planets crumble, black holes vanish, but the universe could keep going indefinitely. That said, its future is anything but lively. Right now, the universe is past its prime. The cosmic baby boom, when stars formed like crazy, happened billions of years ago. In another 100 billion years or so, most galaxies will stop forming stars entirely, and the lights will slowly dim. But what happens to the universe itself? Since 1998, we've known that the universe is expanding faster and faster, thanks to something mysterious called dark energy. Many astronomers believe this expansion will never stop, which means galaxies will keep drifting farther apart. One day, they'll be so far away from each other that their light will never reach us. The universe will become a cold, dark, and lonely place. The very end game is still a mystery. Maybe over an unimaginable period, all matter will break down as elementary particles decay. Or perhaps dark energy will grow stronger, stretching space so violently that it rips apart galaxies, stars, planets, and even atoms in a catastrophic Big Rip. Whether it fizzles quietly or ends with a cosmic bang, one thing is certain. The universe's story is far from over because we are still searching to know, could the universe have been different? The universe we live in is like a finely tuned machine, with its parts, the elementary particles and the four fundamental forces, working together in a delicate balance. Physicists can measure things like the mass of protons compared to electrons, the strength of gravity, and constants like the speed of light. But here's the mystery. No one knows why these values are what they are. Next, could the universe have been different? Technically, yes, but even a tiny tweak to these cosmic settings would have drastic consequences. For example, if the forces that hold atoms together were a little weaker, atoms wouldn't form, and there would be no stars, planets, or life. If gravity were slightly stronger, the universe might have collapsed in on itself long ago. It's as if the universe is perfectly calibrated to allow complexity and life to exist. This precision raises a mind-boggling question. Is it just a lucky coincidence, or is there something deeper going on? If these properties were set randomly, it feels almost impossible that everything would line up so perfectly. Some scientists wonder if there could be countless other universes, each with different settings, and we just happen to live in one that works. The idea of the universe being fine-tuned for life can feel like winning the ultimate cosmic lottery. If there's only one universe and it happens to be life-friendly, it's hard not to wonder, why this one? Why not a universe where nothing works for life at all? One possible explanation is the multiverse theory.
The idea here is
our universe is just one of countless others, each with different properties and constants. Every possible combination of forces, particle masses, and physical rules might exist in this vast ensemble of universes. Naturally, we find ourselves in one of the rare universes where life is even possible, because if it weren't, we wouldn't be here to ask the question. This idea isn't as out there as it might seem. History shows us that people once believed Earth was unique, then the Sun, and even the Milky Way. Science expanded our perspective each time, showing us we're part of something much bigger. But the multiverse theory has its critics. Since it's nearly impossible to test or observe other universes, some scientists argue it falls outside the boundaries of science. To them, it's more philosophy than physics. Whether you embrace the multiverse or find it hard to swallow, it highlights one undeniable truth. The universe is a strange and mysterious place. This big space is full of questions that challenge our understanding of existence, and we still haven't answered the question of whether there's life beyond the Earth. The idea of life beyond Earth is one of the most exciting mysteries in science. The numbers are staggering. There are 100 billion galaxies in the observable universe, each home to billions of stars. Many of these stars have planets, and even if life is incredibly rare, let's say it emerges on only one planet in a trillion, there could still be a billion planets out there harboring life. But numbers alone don't confirm anything. To answer the question for real, we need proof. So far, Earth is the only planet where we know life exists, but that doesn't mean it's the only one. Our own solar system has some intriguing candidates for microbial life. Mars, with its history of water, is a top contender. Then there's Europa, a moon of Jupiter, which has a hidden ocean beneath its icy surface. And let's not forget Enceladus, one of Saturn's moons, which spews water-rich plumes from its interior, suggesting a warm, salty ocean below. Whether we find microbes under Martian soil or alien fish swimming in Europa's ocean, discovering even the tiniest life form beyond Earth would be one of humanity's greatest breakthroughs. The discovery of even the tiniest Martian bacteria would be a game-changer. It would mean life isn't just an Earth thing. It's something the universe does, potentially everywhere conditions are right. So far, though, we haven't found definitive signs of life on Mars, despite plenty of evidence that the planet was once warmer, wetter, and possibly more hospitable billions of years ago. But scientists aren't stopping there. They're now studying the atmospheres of exoplanets, planets orbiting stars beyond our solar system. It would be a huge clue if we detect large amounts of oxygen and methane together in an atmosphere. Why? Because on Earth, those gases only coexist in abundance thanks to life. Life here took billions of years to evolve from microscopic forms into anything more complex, so microbes might be the best bet for finding life elsewhere. Searching for microbes limits us to nearby planetary systems, which are easier to study. That's why some researchers take another approach, listening for signals from alien civilizations. If intelligent life exists, its radio signals might be detectable even across the galaxy. So far, the cosmic radio silence persists. The question of extraterrestrial life remains a tantalizing mystery. For now, it's still a hypothesis we can't prove or disprove. Until we find something, the debate will continue, with some believing we just need to keep looking. After all, in a universe as vast as this, who's to say what surprises might be waiting? Speaking about surprises, we already know of one that remains a constant mystery: black holes. Black holes are some of the universe's weirdest and most mysterious objects. They form when matter gets squished into an incredibly tiny space, creating gravity so strong that no light can escape. This makes black holes completely invisible. We can only detect them by the way they affect nearby objects. There are different types of black holes. The smallest ones are thought to have a mass similar to a large mountain. In contrast, the biggest ones, called supermassive black holes, can have the mass of over 1 million suns combined. These gigantic ones often sit at the center of galaxies, including our own Milky Way. But what about Earth? Could a black hole destroy us? According to NASA, we're safe. There isn't a black hole near our solar system that could pull us in. And despite their reputation, black holes don't go around gobbling up everything in sight. So, while black holes are fascinating and a little scary, there's no need to worry about one ruining our day here on Earth, at least not anytime soon. But we may have to worry about something: dark energy.
This weird type of energy seems to defy our laws of physics and has properties that our current models just cannot explain.
Dark energy might have a cool name, but it's also one of the biggest mysteries in science. Discovered in 1998, it's the strange force causing the universe to expand faster and faster over time. This was unexpected because the gravitational pull of galaxies should be slowing the expansion down. Instead, something is acting like a cosmic repellent, pushing everything apart, and that something is what we call dark energy. Dark energy is a major player in the universe, making up about 70% of it. While dark matter works like glue, holding galaxies together, dark energy seems to do the opposite. It's so powerful that it could eventually tear the entire universe apart. But where does it come from? Some theories suggest it's created by collisions between quantum particles, but no one knows. Scientists are confident that dark energy rules out the idea of an oscillating universe that collapses and then restarts in a big bounce. Beyond that, there is still so much we have to learn about the universe we call home, like what universe are we in? That's a mind-bending question, and scientists have been developing some fascinating ideas to answer it. One popular concept is that our universe might be part of a multiverse, a giant cosmic foam of bubble universes. Here's how it works. After the Big Bang, our universe went through inflation, a mind-blowing period of rapid expansion. Some scientists think this expansion happened to not just one universe, but to many. Each universe would be like a bubble in a frothy cosmic bath, endlessly inflating and expanding. Our bubble is just one among countless others. If this is true, it could explain why our universe has the particular laws of physics it does. Gravity, the weight of particles like protons, and the strength of fundamental forces might just be the unique setup of our bubble. Other bubbles could have entirely different physics, creating universes with strange rules, maybe ones where life, or even matter, couldn't exist. Another idea focuses on the nature of matter itself. At the tiniest scale, inside atoms are particles like protons and neutrons, made of even smaller particles called quarks. Some theories, like string theory, propose that these particles aren't points but tiny vibrating strings of energy. The way these strings vibrate could help explain the properties of our universe, and why it's different from others if they exist. So, are we living in a bubble or a universe of strings? Or better still, what is the universe made of? The truth is, no one really knows. The stuff we're familiar with, atoms and molecules that make up stars, planets, and us, is only a tiny part of the story. It's like the visible tip of an enormous iceberg, while most of it remains hidden beneath the surface. The bulk of the universe is made up of mysterious substances called dark matter and dark energy. Dark matter, which makes up about 27% of the universe, doesn't emit, absorb, or reflect light, so we can't see it directly. We only know it's there because of its gravitational effects. For example, it influences how galaxies spin, move within clusters, and how light bends as it travels through space. Even stranger is dark energy, which makes up about 70% of the universe. It's the force driving the universe's accelerated expansion, acting like a cosmic repellent. It's as if the vacuum of empty space itself has energy, pushing galaxies farther apart. In total, the familiar matter we can see and touch accounts for just 5% of the universe. The rest, the dark matter and dark energy, is a mystery. Observations suggest there's roughly 30 times more matter than we can see with telescopes, so what's the deal with the unseen stuff? Could it be hidden in things like dim stars, cold gas clouds, or black holes? It sounds reasonable, but unfortunately, the answer is no. If dark matter were made of ordinary particles like protons and neutrons, the baryons that make up atoms, the universe would look very different. For instance, nuclear fusion created the elements we see today during the Big Bang. If too many baryons existed, fusion would have produced far less deuterium, heavy hydrogen, than we observe. The evidence just doesn't add up. So, if the Big Bang theory holds true, and all the data says it does, then most of the universe is really made of some kind of exotic, mysterious particles we don't yet understand. These particles don't emit or absorb light, making them invisible, but their gravitational effects reveal their presence. The makeup of the universe is one of astronomy's most profound mysteries. We've gathered many clues, but we're still staring at a half-finished puzzle, unsure of what the final image will reveal. For now, dark matter remains a riddle wrapped in the fabric of the cosmos.